Hello, everyone. I'm Kerry Cole, editor of Materials Performance Magazine with AMP. And today I'm here with Buddy Damm of Swagelok Company. Buddy, thanks for being with
Well,
us.
thanks for having me, Kerry.
Can you please tell us a little bit about Swagelok and your role with the company?
Yeah, Swagelok's been around a little over 75 years. We make fittings and valves, regulators, fluid control components, and are used an awful lot in the oil and gas environment.
And you were their senior scientist of metallurgy, is that?
That's right. Yeah, I'm a senior scientist in metallurgy, so I get involved in developing new products and supporting existing products, as well as helping support customers with training and material science knowledge.
Okay. Well, today we're going to be talking a little bit about corrosion, some of the factors that lead to corrosion, and Swagelok's role in helping find solutions. So can you tell me what are the conditions that result in corrosion and what makes certain environments more corrosive than others?
Yeah, so corrosion occurs as a result of an electrochemical reaction. So the electro part of that reaction, meaning an electron is involved, and the chemical being that an ion or piece of the metal is reacting. And so this electrochemical reaction happens in electrolyte, typically water, and can be thought of a lot like a battery. So a car battery generates electricity through an electrochemical reaction. Um, Environment, so things like tap water is a relatively mild corrosive, not very hard to manage. But then you get into seawater, and there's chloride ions, and those chloride ions make the water more aggressive. And then in the oil and gas production environment, the fluids coming from downhole could contain other corrosive species like hydrogen sulfide or chloride, chloride, or they may be acidic.
And can you explain why corrosion can become such a problem for oil and gas operators? And how common of a problem is corrosion for oil and gas systems?
Yeah, so corrosion is a major problem for oil and gas producers, pulling hydrocarbons out of the ground. For one thing, you need to have a very safe containment because the fluid often contains hydrogen sulfide, which is deadly. But also just the loss of material due to corrosion requires lots of preventative maintenance costs. So it's ubiquitous in the offshore environment for sure.
And what are some of the types of corrosion that operators can encounter?
Yeah. So uh, helpful to think of corrosion on an offshore platform in two ways. One is externally influenced corrosion, and one is internally influenced corrosion. So from an external perspective, you're in a seawater environment, and so you have chloride ions in the environment, and you have wet and dry cycles. So those wet cycles will dilute the environment, but then the dry cycles will create a more concentrated and more corrosive environment and attack the material. From the inside, you've got hydrogen sulfide, which is a corrosive. You've got chloride ions, usually have a low pH or an acidic solution. And those things act together to have a corrosive attack on the material. And in addition to that, you have to contain the pressure. And so stress resulting from pressure containment can act in conjunction with the corrosion process to create damage.
I see. How can understanding the factors associated with corrosion help in terms of material selection?
So when you have an understanding of the different types of corrosion processes, then you can get to the root cause when you have problems or and solve those problems. So, for example, if you have a pitting or crevice corrosion problem, understanding the effect of the passive oxide film on the surface and its ability to resist pitting or crevice corrosion cracking allows you to understand that choosing an alloy with a higher chrome or molybdenum or nitrogen or all three will provide a more robust solution in that environment. In the case of internal cracking associated with the complex environment from downhole, you've got many factors happening at once. So you have hydrogen sulfide, you've got chloride. Typically, you have hydrogen evolution either as a result of corrosion or perhaps due to cathodic protection. And all three of those things, when combined with stress, can result in environmentally assisted cracking. The NACE MRO 175 or ISO 15156 standard, helps to define what kind of alloys are appropriate for use in different ranges of those different species. So certain chloride concentrations, certain pH, certain temperatures will drive the need for a more corrosion-resistant alloy, depending on what your environment is.
And what resources does Swagelok offer to help educate system operators? And where can people go to learn more?
Yeah, our website has a lot of information. Of course, corrosion is a critical topic to our products and our customers. And so we have information on selection of alloys for corrosion resistance, the different types of corrosion resistant alloys, the types of products we make that are NACE compliant. And we also have a link to our training information. And we have a series of videos called Ask Swagelok that cover a whole range of topics, including corrosion, and can be very helpful, brief videos to help learn about a subject.
Very good. Thank you. Again, I'm Kerry Cole, editor of Materials Performance Magazine, and we're here with Buddy Damm, who's a senior scientist of metallurgy with Swagelok. And thank you so much for joining us.
Thanks, Kerry. Have a great afternoon.